We have to take in each and every gate in detail, like what is how buffer is using actually into the real digital circuit. So we will going to cover it each and every gate one by one. Okay.
Okay.
So first one is buffer gate. Put the side heading. Now you will going to see what is exactly the working of buffer gate in real world. So what is the output of buffer gate? Yeah. Output is same as input, but we have to provide some delay on this. Especially this buffer gate is basically used for providing some delay on, but provide a short delay. Okay, suppose if you wanted to give some amount of delay on your system, now on that time buffer gate is very crucial for us. Like suppose in your home the current is flowing 5 ampere and you want like this particular current unit is very high. So if you want your current unit around 2.5 ampere, on that time you will going to give lots of buffer on your entire circuit designing. Okay, so that circuit designing will give you the same output, but the taking some of the delay on it. Like here it is the normal wire. Okay, hello. Yeah, this carry 5 ampere of current, but you not wanted this complete 5 ampere of current. You need at least 5 to 10 at least 10 seconds to reach this 5 ampere current from one side to another side. But this 5 ampere of current onto the output you directly got from within 2 seconds. So this at some point of time you definitely this will harm your system. So to overcome from that particular problem, you are providing so many number of delays or so many number of buffer gate on your system. So every buffer gate will take some of the delay charges on it, like this. So this particular buffer take 3 unit of delay, this 3, this 3. So previously one current travel from one particular point to the other point in 2 seconds. After applying this particular buffer gate, it will take 2 seconds, 3 seconds, 3 seconds and 3 seconds. So total 8 seconds. Okay, hello. Yeah, I'm so sorry. 9 plus 2 11. Yeah. So previously, any of the current is the some amount of current is travel from one side to another side in 2 seconds. After taking the buffer gate as an input, on that time your current will take 11 seconds of time to reach to the output side. So the basic functionality of that particular buffer is this only. You are directly giving the delay to your system. So types of buffer are, there are two types of buffer. First one is bi-state buffer and second one is tri-state buffer. First one is bi-state and second one is tri-state buffer. Okay, Now, what is bi-state buffer? The symbolic representation of bi-state buffer is like this: A, like this. Okay. The normal buffer is known as bi-state buffer only. Yes, yeah, no. What is the actual output of this? That A only. TT. So A and output is Y. So if I'm providing 0, then 0, and 1, then 1. Okay. Now, in circuits, there are two types of signal flow is there, right? First is analog signal and second one is digital signal. So how this buffer will going to work on both the types of signal? Like here, this is the actual functionality of this buffer. If I'm considering any analog signal, so the flow version of analog signal is like this. Okay, the analog signal will flow like this. Once you start switching, then immediately it will jump from lower value to the higher value and continuously it flow to the same manner. Right? Suppose if you want to switch your fan, you directly click on your button. Immediately that fan is start running. It means your voltage is turn out from off condition to the on condition. Yeah, but whenever you are applying any buffer circuit on your constructor side, or you can say that on your capacitor, inside the capacitor of your fan, on when you are applying so many number of buffer logic gate, so it means indirectly you are providing some of the delay onto the system. So here I am applying some delay. Like if I'm applying 0 delay, then what's the actual output? The same output which you wanted, getting the same output. But if I'm applying some of the delay, like 3 nanosecond or 5 nanosecond, just to apply this amount of delay, just because I do not want my circuit to be harmful, so it will going to give me the output after 3 nanosecond. So this much amount of delay that system will gonna take. Okay, so now you know the basic functionality of that bi-state buffer. It's just used for providing some amount of delay to your system. Yes, yeah, no. Okay, second point is tri-state buffer. What is tri-state buffer? Whenever you are providing any controlling to any particular control signal na, so that control signal is going to be handled by the admin only. Like if I wanted to control my circuit, then definitely that circuit designing should be framed like that whenever I wanted to control that system, the main control signal is from my side only, like here. So the actual designing of buffer is this: when you are providing 0 on this particular signal, control signal, on that time it will act as like a bi-state buffer. Okay, this wire is cut off on that time. But when you are providing control signal as 1, on that time your bistate buffer will act as like a open wire. Hello.
Yeah.
So let me redraw with this. So suppose if you are providing C is equals to 1, on that time this complete wire is connected with your system, right?
Mm-hmm.
Yeah. So it means this particular control signal states that you are able to use this particular buffer gate on your system. There is no cutoff, there is no delay on this. You can directly use this system on your function like this. But when you are applying 0 on this, it means you wanted to open this logic gate, and maximum amount of voltage will going to be appear on that time when your controlling signal is equals to 0. On that case your bistate buffer will move directly onto high impedance state. Your wire is cut off from that particular point, and this state is known as high impedance state. So whenever your circuit is open, on that time what is the value of current
0.
and how much amount of voltage will appear on that case?
Mm, 0.
Maximum voltage. Okay,
Oh.
so current and voltage are both are the replica. Whenever there is a open wire, it means no current will gonna flow on that wire, but maximum amount of voltage will going to be appear on that state.
Okay.
So this thing you have to be understand. Whenever there is an open wire, it means no current is flowing, so maximum amount of voltage will going to be appear on that state.
Okay. Current equals 0 and
Yeah,
voltage equals 1.
yeah. So I equals 0 and V equals V max. Okay. Have you ever seen this thing whenever there is no obstruction or there is no disturbance on any wire, how much amount of current is flowing on this wire? Suppose this is a single line wire. I wanted to check how much amount of how much amount of current is flowing on this. So you can tell maximum amount of current will going to flow on this wire, just because there is no resistance, there is no disturbance, there is no abundance is showing on this particular wire, right?
Yeah.
So maximum amount of current. So how much amount of voltage will going to be appear on this wire?
Minimum.
Yeah, minimum it means 0, right?
Okay.
Yeah. So a single line wire will produce you maximum amount of current and 0 voltage, whereas the open wire will give you 0 amount of current and maximum voltage.
Okay.
Yeah. Second is NOT gate. We will going to see the combined question of both buffer and NOT gate. Okay.
Okay.
Any doubt on this buffer?
Mm, no.
We will going to see how question will come on this particular topic. First, let me complete the NOT gate also, because the questions are combined on this by merging both the topics. Do you know the symbolic representation of NOT gate?
Yeah.
Yeah, tell me.
Buffer gate with a circle.
Like this, right?
Yeah.
Okay, the alternative representation form is this. You can apply that bubble either from the top side or to the bottom side.
Okay.
So what's the output? A bar. In both the cases, the output will say. Okay. If I'm asking the TT, then
0, 1, 1, 0.
if you wanted to note all these points, you can parallelly note it down also. Our agenda is to complete the question related to this.
Okay.
So do you want to note these points?
I am writing down.
Okay, that's great. What is logical expression? A bar, right? Hello?
Yeah.
Hello?
Hello.
Yeah, the logical expression is A bar, right?
Yeah.
Okay. Now, suppose if I'm taking an analog circuit input onto the NOT gate, output will be A bar. It means if your circuit flow is like this, and if I'm providing zero amount of delay on it, can you tell me the final answer? And if I'm providing 5 unit of delay, on that case, what will be the final answer? Hello?
It will go down. Like it will be like 0 and then it will go down.
Here it is 0 and then 1. In this case,
It will go down.
like this, right? So from 1 to 0. Okay. What about this TPD 5 nanosecond? If I'm providing 5 nanosecond of delay on this system, then
Then it will go a little farther and then go down.
okay, it means for 5 per second it will remain as 0 state, and then after it will going to change the state from 0 to 1. Sorry, from 1 to 0. Okay. So this much amount of delay we will going to take. So all the electricity department will use all these amount of NOT gate and buffer gate on their system. Basically, inverter memory devices are used to implemented by these logic gate, by these buffer and NOT gate only.
Okay.
Now I will going to tell you how these inverters, the inverter, the basic functionality of inverter, how it will going to implement, how it will going to frame internally. Okay, we're going to see it. First, write the definition. First, note this heading: cascading of NOT gates. Cascading means combine several number of gate into a single system. Okay.
Combine several gates
into a single system. So first is cascading of even number of gates. You can write cascading of even number of gates. Definitely you will going to love this particular concept after just after half an hour. I just need to complete that point first. Okay, can you tell me the final output of this? Air. A, right? Write one note. Assembly of even number of assembly of even number of cascaded NOT gate behaves as bi-state buffer. Behave as bi-state buffer. Now, second point is cascading of odd number of gates. So if I'm going to add odd number of gates on that case, A, in this case I think the output is A bar, right? So this will give you A bar, then A, and then A bar. So notice assembly of odd number of gates behaves as inverter. Okay.
Okay.
Any question on this point?
No.
Okay. Now this particular point is very important, which we will going to cover now. Not gate with feedback. Most of the time examiner will directly going to ask the question from this point only, because this will tell you so many number of applications. In the market also so many applications are available based on this topic. Not gate with feedback. So very IMP. So first point is odd number of NOT gates with feedback. Odd number of NOT gates with feedback, right?
Yeah.
सो इसमें लिखना ट्रिगर व्हेन इनपुट सप्लाई इज present for short duration. It means where you giving an input like just applying as a circuit is on and then directly you switched off. So that is a trigger point. Now here if you are using a NOT gate, odd number of NOT gate, but as a feedback loop like this. Okay, so if you are applying 1 here, so what will be the output on that case? Hello, this is a NOT gate. If you are applying 1 here, then what you will going to get in the output? 0, right?
Yeah.
What's the opposite of 1? That is 0 only.
Yeah.
So you will going to collect an output 0. So suppose create one picture. You can directly switch on your fan and immediately within a second you directly switch off. So this particular NOT gate will give you an output 0, right?
Yeah.
And then if you are applying as in loop, then this particular output will act as like an input also. Next time, without applying any input, your system will take 0 as an input
Okay.
and it will generate an output 1. Again that 1 will going to act as an input and it will generate an output 0. Then 1, then 0, then 1 and then 0. And this phenomena will continuously going on. So when when odd number of NOT gate with feedback, on that time your output will going to be triggered continuously after applying a single input. And that input you have to be given only one time. Next time that circuit will immediately taking the input from themselves.
Okay.
Getting my point or not? So all your entire digital circuit are framing like this only. You have to be directly giving one switch now. Every time when you are giving a switch as 1 on your fan, that fan is continuously rotating. You are not giving multiple number of input. You are giving only one input at a time. After that, at the end, if you are applying 0, immediately it switched off. But so many times you have to be apply. Do you have to be applying multiple number of times of input onto the on your switch? No, right?
No.
Immediately that particular circuit, suppose you are switching on your fan, you given you are triggering as like on. Immediately that circuit will start working and your fan is start rotating, and that is continuously rotating. That fan is never asking you to giving me so different input. It directly depend on to the voltage it will generate an output and your fan increase start rotating continuously onto the same speed.
Okay.
So this functionality is working on each and every digital circuit design. Like here, This is a small amount of switch which I am using. Okay, this is a small switch like on and off. This 1 tells you on and this 0 tells you on. So this is a small clock. Okay, yes, yeah, no.
Yeah.
Now this particular or NOT gate is taking some TPD amount of delay. Yeah, so your cycle will going to be work like this TPD amount of delay. Okay, immediately it will going to take inverted input value. Like if I'm giving high, then it will generate low output, and if I'm giving low, then it will generate high output, right? So here if I'm, your circuit will going to be work like this only. Yes, yeah, no. Your circuit will going to be work like this. Continuously it oscillates from the same frequency. Any problem on this?
No.
Every time it will going to take the same amount of delay, TPD delay only. Request you please ask any question if you have any doubt on this particular form. Okay, initially it's in switch off state. Immediately when you are switching on, it takes that same amount of delay which you are providing on your circuit, and then it will inverted value, low to high and high to low, and this particular cycle will going to be given as an output on your CRO system.
Okay.
So this particular system is a most basic type of system. Okay, so what all the important points you will going to cover from this particular cycle? First one, this is actually related to your practical also. First one, this cycle is known as astable multi-vibrator. So in your Viva, if anyone is asking you explain about the stable multi-vibrator, on that time you can say the odd number of NOT gate is connected with the feedback loop, that is known as astable multi-vibrator. Output of the system remain in two unstable state. Okay, astable multi-vibrator. Next is this particular cycle is also known as square wave generator. Okay, there's so many alternative name of this. First one is astable multi-vibrator, second one is square wave generator, third one it is also act like a because you are giving a clock onto the input signal, right? So clock is a petrolic electrical signal having some duty cycle. Duty cycle means that amount of delay you are providing onto the system, having some duty cycle. Patrolling means that is an input signal which you are giving. So there are alternative types of input signal, right? Like you are giving switch on switch off type, you are giving input signal or electrical signal directly. So if you are having multiple number of triggering switching circuit, you can tell that is a patrolling electrical signal. Okay, hello. Having some duty cycle means you are providing some amount of delay on that system or onto that logic gate. Hence above circuit also known as what is also known as clock generator. Okay, above circuit is also known as ring oscillator. So these are the alternative names of this particular square wave generator. Just after taking this NOT gate into a feedback loop, immediately you no need to giving the multiple number of time input. That circuit immediately fetching the output as an input and generates plenty number of outputs. Now, if I'm asking you, do you have any idea about the time period? What is the time period of this particular system, for this particular signal? Okay, what is the time period means?
Oh, twice.
Very good. What is the time period? May I know the definition of that?
That is the way comes back to the
Very good. So the time period equals what? Twice of TPD, or we can say twice of number of NOT gate in loop. Okay, because if suppose if this NOT gate is having if you are taken 3 NOT gate into a single circuit, then on that time definitely this TPD will be changed, right? Or some differ from the original time period.
Okay.
So we can say now that time period directly depend on to the number of NOT gate also.
But still, what if every energy has a different amount of delay?
Very good question. Yeah, very good question. Here we will take I will definitely cover that point also, but here you will consider all the delay having the same amount of propagation or duty cycle.
Even then, it's not mentioned like what if our TPD is
5 nanosecond.
yeah.
Yeah,
You're saying number of energy. You're not saying 5 into 5 into 5 into 5 or 5 number of energies.
yeah, I totally agree with you, but on suppose your number of NOT gate is 2 TPD, okay,
Yeah.
like this. So on that time your time period is 4 into 5, that is 20. So that NOT gate will definitely come out with their duty cycle also, no?
But it's just number of energies. How can it be 2 TPD?
Number of number of NOT gate with their duty cycle you can mention also, okay, with their duty cycle. So number of NOT gate with their duty cycle in loop. Clear? What about the frequency?
1 over time period.
Very good. So in this case the frequency is 1 by 2 TPD, right? Okay, please note this particular point, then we'll go into the next question.
Sure, President.
Okay.
So when we stop here for the
uh, we not covered even 1 hour today.
day? You want to make the one.
uh, if it is possible, can you just give me one or two solution of my questions, so that I can also understand whether this topic is understood or not.
Okay.
Do you feel boring this particular topic now?
Yeah.
And just after this not gate now, other gates are very interesting then. Now from here, all the numericals are there, but these theoretical points are also very important just for your theoretical purpose. If you are working only for competition, on that time I will directly giving you highlighting like what is a stable multivibrator, like this, but you also need to deal with your university papers.
I will I won't be giving competitive either. So I will keep it for competitive. I will be giving for university.
Yeah, that's that's the main thing. So I need to cover each and every point just for your university purpose. If anyone is asking you what is clock generator, on that time, definitely you know some of the backend side that this is the formation. But if I'm not covering this complete cycle diagram and a stable multi-vibrator duty cycle, definitely you will going to stuck on that time. Like sir is already taught me about this clock generator, but there is no alternative way of this clock uh, in this figure and anything else. That's why I need to cover each and every point. Okay,
Yeah.
can you tell me the, can you show me that picture diagram of this particular output? What is the time period for this cycle, for this particular NOT gate system?
3 TP.
Time period I'm asking.
6 TP. 6.
6 TPD, right?
Yeah.
Sure.
Uh, no, it should be 3 TP.
3 TPD or
Oh,
6
6.
TPD?
Oh, yeah, yeah. 6 because it will twice into that.
Oh,
6.
okay. What about this? Yeah, what about this? The delay is same, TPD only. Hello?
Yeah, I was sending you a picture.
What is the time period
6 TP.
for this also?
Oh, for this one, 8.
8 TPD, right? Okay. What about this one then? I know it will take some time to solve. Okay. Tell me the answer. Time period for this. Same TPD delay, okay? Hello? Uh, What about this?
Time period would be 60 minutes.
For this? Talking about first one or the second one?
First one would be
This one?
yeah.
And what about this?
6.
Both 6?
Yeah, because I think so.
Please recheck it once then.
Hmm?
Please recheck it. For second, 6 is correct. Yeah. What about the first? For this one? Yes, 6 TPD is correct. Hey,
Because it will only repeat, you know.
after 3 logic
Yeah.
gate, right? Yeah. What about this then?
I'm confused about it. Like 0 comes in, let's say,
Yeah.
then it goes out as 1 becomes 0 again. But we are taking 1 back. Mm-hmm. 1 goes out as 0.
Okay. First, if I'm taking 0 as an input, okay, then till 4 TPD, I'm not able to perform any of the operation just because I'm taking 4 TPD of delay. First one, second one, third one, and then fourth one, right? Yes, yeah, no. Yes, yeah, no.
Mm-hmm.
So if I'm taking 0 as an input, then you have 1, then 0, then 1, and then 0, right?
Yeah.
Now, this 1 is fetching as an input for first logic gate. Yes, yeah, no.
Mm-hmm.
Then 1 will become 0, then 0 to 1, then 1 to 0, and then 0 to 1, right?
Yeah.
It means again it will going to take 4 TPD of delay.
Mm-hmm.
Yes.
Mm-hmm.
Now on this time 0 as an input, so it will going to change the state from 0 to 1, right?
Why didn't it go up the second time?
Because initially it started 4 TPD of delay,
Yeah.
then you will take 1 as an input. Hello.
Yeah.
Because every time you have to be noted this particular y output, right?
Yeah.
If you're taking 0 as an input and in star at the end you are getting 0 as an output only. So after 4 TPD you are providing you are taking 4 TPD of delay initially. Give me a sec. Initially you are taking 4 TPD of delay. When you're taking 1 as an input, on that time still you are taking 4 TPD of delay. That's why I'm taking 4 TPD of delay again. Now your answer will be 1. So I'm changing my state from 0 to 1, right? Now here 0 comes again, and it will going to invert its value 0 to 1, then 1 to 0, then 0 to 1, and then 1 to 0. So 4 TPD of delay again, and after 4 TPD of delay it will going to change the state from 1 to 0. Agree? And now the cycle will going to flow like this: 4 TPD, 4 TPD, 4 TPD every time. Yes? Yeah. For this case, time period is 8. So these all are the questions which they ask from the NOT gate. You have to be use plenty number of NOT gates or cascading of NOT gate to create a stable system, or to make accurate time stable system. Okay, so write this summary directly. Time period equals what? 2 times of number of plus number of buffer also, right? Because if you are adding buffer on your system, still it will affect the time period. Yes or no?
Yes.
Because in the first case you are taking buffer as an as one logic gate into TPD. You can write like this: so twice into number of NOT gate plus number of buffer into TPD, where N naught is what? Odd or even? It's mandatory that your NOT gate should be odd in number.
Okay.
Because if your NOT gate will become even, on that case you will not going to get any TPD or any time period, because every time you will get the same output, 1 1 1 1 1 1 1. So if your cycle will not change, so definitely will not going to get any time period on that case. So it's mandatory that your N naught should be odd. In this case we are treating TPD as same. So when time delay is same, on that case your time period is will like this. When your time period is different, on that case when time delay is different, इस केस में क्या होगा? Like 2 into TPD1 plus TPD2. TPD3 and then 2 n terms. Do you know APGP, right?
No.
Yeah, the formula of sum of n terms of GP is so many times now they will check your mathematics on this concept also. Okay, have any idea about the difference between AP and GP? Yeah, I just want to know the difference. Okay. So suppose if I'm asking you, like you have to add all those numbers. To so on till 98. Is these numbers are in AP or GP? AP. So what is the basic approach to understand about the AP and GP? That is the common difference, right? Here the common difference is 2. For every, if you are applying the difference of each and every number, you can see this, that every time the difference coming is 2. So without using the calculator, without using any of the without using direct addition, you arithmetic progression will give you one formula. That formula is known as n by 2 a plus l. This is the formula, because they will going to ask these questions to you directly on this number of delays, because this is the only approach they wanted to take. If you wanted to use this formula, you can use it directly. Like there are how many number of terms are here, starting from the 2 till 98. How many terms are there? 50 or 49? 49, right? So 49 divided by 2, a plus l. A is first term and l is the last term. So it means 50 into 49. So, yeah, the beauty of this formula is this one. Then what's the final answer of 49 fives are? I don't know. So 9 fives are is 45 and 40 fives are is 200 now. So you can say 2, 4, 5 and then 0. This is the final answer. 2450. If you not wanted to use this formula, there is one more. N by 2, 2a plus n minus 1 into d. You can also use this formula. Okay. Hello. Suppose if you wanted to find out the total number of terms, on that case the formula is a plus n minus 1 into d. For n terms, if the user asking you find the nth term of AP, the respective nth term. On that case, the a plus n minus 1 into d. This formula is sum of all the terms, and this is the alternative formula of sum of all the terms. Now my next question is, if I'm asking you like 2, 4, 8, 16, 32, 64, blah 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 blah, 1024, like this. So are these numbers are in AP or GP? Okay. What is the common difference between them? Here the 4 by 2, it's 2, right? So in this case you have to check the common difference by dividing two numbers, the second with the first, right? If I wanted to ask you the sum of n terms of GP, so the formula is a r to the power n minus 1 upon r minus 1. Okay, and suppose this number is having no end, it means it is moving till the infinite. On that case, you can use a simple approximation formula, that is a upon 1 minus r directly. Okay, and the sum of the nth term of GP is what? Yeah, a r to the power n minus 1. Okay, so might be possible they will going to take all those input delay on the GP basis or the AP basis. So they will going to cross check that whether you have this time period knowledge or not, or if you having, so whether you have a bit idea about this sum of all the n terms or GP or AP. Okay, so from the tomorrow onwards we will going to cover the interesting gate and switching circuits. Definitely from the tomorrow we will going to directly jump onto the some of the interesting topic like NAND gate, NOR gate, AND gate, and what are the functionality of.
Okay. Sounds good.
Okay, then till